Question No. 1. A gaming company is building a serverless data lake. The company is ingesting streaming data into Amazon Kinesis data streams and is writing the data to Amazon S3 through Amazon Kinesis Data Firehose. The company is using 10 megabytes as the S3 buffer size and is using 90 seconds as the buffer interval. The company runs an AWS Glue ETL job to merge and transform the data to a different format before writing the data back to Amazon S3. Recently, the company has experienced substantial growth in its data volume. The AWS Glue ETL jobs are frequently showing an out-of-memory error. Which solutions will resolve this issue without incurring additional costs? Choose 2. E. Place the small files into one S3 folder. Define one single table for the small S3 files in AWS Glue data catalog. Rerun the AWS Glue ETL jobs against this AWS Glue table. B. Create an AWS Lambda function to merge small S3 files and invoke them periodically. Run the AWS Glue ETL jobs after successful completion of the Lambda function. C. Run the S3 dist utility in Amazon EMR to merge a large number of small S3 files before running the AWS Glue ETL jobs. D. Use the groupful setting in the AWS Glue ETL job to merge small S3 files and rerun AWS Glue ETL jobs. E. Update the Kinesis Data Firehose S3 buffer size to 128 megabytes. Update the buffer interval to 900 seconds. Answer: a D. Question Note 2. A company is streaming its high-volume billing data, 100 Mbps, to Amazon Kinesis data streams. A data analyst partitioned the data on account_id to ensure that all records belonging to an account go to the same Kinesis shard and order is maintained. While building a custom consumer using the Kinesis Java SDK, the data analyst notices that sometimes the messages arrive out of order for account_id. Upon further investigation, the data analyst discovers the messages that are out of order seem to be arriving from different shards for the same account_id and are seen when a stream resize runs. What is an explanation for this behavior and what is the solution? E. There are multiple shards in a stream, and order needs to be maintained in the shard. The data analyst needs to make sure there is only a single shard in the stream and no stream resize runs. B. The hash key generation process for the records is not working correctly. The data analyst should generate an explicit hash key on the producer side so the records are directed to the appropriate shard accurately. C. The records are not being received by Kinesis data streams in order. The producer should use the put records API call instead of the put record API call with the sequence number forwarding parameter. D. The consumer is not processing the parent shard completely before processing the child shards after a stream resize. The data analyst should process the parent shard completely first before processing the child shards. Answer: Question No. 3. A data analytics specialist is setting up workload management in manual mode for an Amazon Redshift environment. The data analytics specialist is defining query monitoring rules to manage system performance and user experience of an Amazon Redshift cluster. Which elements must each query monitoring rule include? E. A unique rule name, a query runtime condition, and an AWS Lambda function to resubmit any failed queries in off hours. B. A queue name, a unique rule name, and a predicate-based stop condition. C. A unique rule name, 1 to 3 predicates, and an action. D. A workload name, a unique rule name, and a query runtime-based condition. Answer: C. Question No. 4. A company provides an incentive to users who are physically active. Company wants to determine how active the users are by using an application on their mobile devices to track the number of steps they take each day. The company needs to ingest and perform near real-time analytics on live data. The processed data must be stored and must remain available for 1 year for analytics purposes. Which solution will meet these requirements with the least operational overhead? E. Use Amazon Cognito to write the data from the application to Amazon Dynamod. Use an AWS Step Functions workflow to create a transient Amazon EMR cluster every hour and process the new data from Dynamod. Output the processed data to Amazon Redshift for analytics. Archive the data from Amazon Redshift after 1 year. B. Ingest the data into Amazon Dynamod by using an Amazon API Gateway API as a Dynamod proxy. Use an AWS Step Functions workflow to create a transient Amazon EMR cluster every hour and process the new data from Dynamod. Output the processed data to Amazon Redshift to run analytics calculations. Archive the data from Amazon Redshift after 1 year. C. Ingest the data into Amazon Kinesis data streams by using an Amazon API Gateway API as a Kinesis proxy. Run Amazon Kinesis Data Analytics on the stream data. Output the processed data into Amazon S3 by using Amazon Kinesis. D. Data Firehose. Use Amazon Athena to run analytics calculations. Use S3 lifecycle rules to transition objects to S3 Glacier after 1 year. E. Write the data from the application into Amazon S3 by using Amazon Kinesis Data Firehose. Use Amazon Athena to run the analytics on the data in Amazon S3. Use S3 lifecycle rules to transition objects to S3 Glacier after 1 year. Answer C. Question No. 5. A social media company is using business intelligence tools to analyze its data for forecasting. The company is using Apache Kafka to ingest the low-velocity data in near real time. Company wants to build dynamic dashboards with machine learning, ML, insights to forecast key business trends. The dashboards must provide hourly updates from data in Amazon S3. Various teams at the company want to view the dashboards by using Amazon QuickSight with ML insights. The solution also must correct the scalability problems that the company experiences when it uses its current architecture to ingest data. Which solution will most cost-effectively meet these requirements? E. Replace Kafka with Amazon Managed Streaming for Apache Kafka. Ingest the data by using AWS Lambda, and store the data in Amazon S3. Use QuickSight Standard Edition to refresh the data in Spice from Amazon S3 hourly and create a dynamic dashboard with forecasting and ML insights. B. Replace Kafka with an Amazon Kinesis data stream. Use an Amazon Kinesis Data Firehose delivery stream to consume the data and store the data in Amazon S3. Use QuickSight Enterprise Edition to refresh the data in Spice from Amazon S3 hourly and create a dynamic dashboard with forecasting and ML insights. C. Configure the Kafka Kinesis connector to publish the data to an Amazon Kinesis Data Firehose delivery stream that is configured to store the data in Amazon S3. Use QuickSight Enterprise Edition to refresh the data in Spice from Amazon S3 hourly and create a dynamic dashboard with forecasting and ML insights. D. Configure the Kafka Kinesis connector to publish the data to an Amazon Kinesis Data Firehose delivery stream that is configured to store the data in Amazon S3. Configure an AWS Glue crawler to crawl the data. Use an Amazon Athena data source with QuickSight Standard Edition to refresh the data in Spice hourly and create a dynamic dashboard with forecasting and ML insights. Answer B.